I don't know why I'm clicking on this. The typo like makes me laugh. I guess that's why. I don't know if I would even be able to do this. Oh wait, no, that's just like A is just a straight up choose. Okay. And that's okay. So it is just a permutation for. Okay, so they I looked up what the answer is, but they're wondering why the answer to part A. I'm confused with what not combination of repetition means. Like, well, why is the not there? I think they just have a misunderstanding what choose. Okay, so their question really seems to be about choose versus permutation. Is it permute? Is there an easy way to say that P? I don't know. That's like less syllables. Okay, so someone did already beat me to it. Let's see what they say though. Okay, so this person's right, but I feel like it's not getting at the heart of what they're asking. So let me post my kind of interpretation of their question, or post an answer with my interpretation of their question, I guess. It's about it's between NCR versus NPR, National Radio, National Public Radio. I should say choosing combination, or choosing permutation, or combination and permutation. Maybe that's even better. I feel weird capitalizing combination permutation. They play the best classical music in the state? Exactly, Jed. We need a national Jed radio, NJR. Oh, someone hopped in the Discord. Welcome to whoever you are. I have streamer mode on, so I can't see names. Oh, Camelot, hey, it's been a while. Glad to have you here again. It left for some reason. Oh, okay. It's weird. Interchangeable. Okay, what's some good like made up names? I want to do like I want to make up four names here. Okay, Zach, Dan, Brian. Wait, what's Stooky's name? I'll say Bob. I don't know Stooky's name. um. Zach is president, vice president, whatever. Where's the fifth person? Don. We only need to choose 4. Thankfully. And in my heart, Zach, you're the president here. It's all treated as one case. Permutation treats category should be best viewed on Twitch. Yeah. Choose one case as long as it's the same for people. Mangoes, hey, how's it going? Getting that pie in there? Love it. So Zach being president is one, Zach being vice president, it's another, etc. Working? I'll take it. I appreciate it. You don't know if you like this being president thing? Yeah, it's a lot of pressure, but if anyone's up to the task, it's you. This is the real analysis committee. Hey, SPQ. Why'd I put a comma there? I just love my commas. You're choosing the same for people. Combination counts it as just one case, whereas permutation counts it as 4 different cases. And we're sure there are 4 different cases because each person can be each different role. Oh wait, no, but you can switch around 2 and hold 1 constant, right? So 4 factorial? Yeah, it's 4 factorial, right? Because the first roll, you have 4 options. The next one you have 3 options. The next one you have 2. The next one you have 1. And 4 factorial is 24. It's 4 times 3 times 2. I hope. I know. Today's. I feel like I'm. I feel like every day is a bad math day for me when it comes to arithmetic. But I think this is right. You guys just not say this. I'm not completely confident in it though. The part above, I'm completely confident in. Let's just say that. Oh, you're doing this. Okay, let's see. I haven't done this with second order differential equations. Even with first order, I am pretty rusty on it. I do really like these two. I just need to remember what's up with them. Okay, so at least you're given the eigenvectors. The eigenvalues. Okay, we can do that. Okay, so it's just gonna be like a plug and chug thing. If you already have the eigenvectors, is there an easy way to get the eigenvalues? Or do you seem to do it the old minus lambda and get it the old-fashioned way? I feel like you can like plug it into the you did lambda? I need to remember like how you get the eigenvectors by doing like lambda times the coefficient matrix times the eigenvector equals 0, 0 or something. Right, A equals V inverse LV. Left right multiply to get VAV inverse equals L. V is your matrix of eigenvectors. L should be the eigenvalues along diagonals. Oh! I didn't know that that was a thing. Okay. So we'll have to do the inverse of the matrix. I don't think that'll be too bad though. I'll leave it like that. Okay. So V is the matrix of eigenvectors. So I don't know if the order actually matters, but I assume not. Yeah, it does seem like they did the hard part for you. Thankfully. Because I don't know if I'd be able to do the hard part. So what Zach is saying is we can do A equals VA inverse V. A is the coefficient matrix. Or, I'm sorry. Yes. And then we take V as the matrix of... Wait, I wrote A twice. Why did I do that? L equals... Because I was reading both of Zach's chat messages with like the formulas. Okay. So A is the matrix we were given, minus 0.7, 0.9, 0.9, 1.7. Of M times V and see how it changed. SPQ says. Maybe, but I don't know what that means. So I'm gonna keep on doing it this way. Do them are 7 out of 10, 9 out of 10, etc. I'm not sure what that means, Camillus. One, 3, 3 minus 1. That feels kind of weird. Like it feels like there's something special with that matrix, but I don't know what it is. 1 over AD minus BC. Minus 1, minus 9. Switch the corners. Negate the other corners. Oh, that's what you're saying with the fractions? Maybe I just hadn't gotten to the part of the problem that you were talking about yet. Rather than 0.7, you did it with fractions. Oh, okay, that's completely valid too. And actually, with I already included fractions here, and I'd rather do it with fractions. Personally. 1.7. That's 1 and 7 over 10 as a mixed number. So that's 17 over 10. I should have been able to do that much quicker, but there you have it. Okay, and so Zach is saying that L is going to be the matrix with the eigenvectors along the diagonals. So let's do V. 1, 3, 3 minus 1. A. Minus 7 over 10, 9 over 10, 9 over 10, 7 over 10. V inverse. 110, 310, 310, minus 110. Okay. $17. Oh, thank you. Good catch. I need to make this window smaller too. Okay, let me come a bit more over to the right so I'm not blocking it with the problem. So let's go left to right on this multiplication, so I'll do that 2 by 2 times that 2 by 2. Give another 2 by 2. Kind of annoying. Minus 7 over 10. 3 times 9. 27 over 10. Then this one goes over there. 9 over 10. Now we do 17 times 3 is 51. That one times that one. That one times that one. I need to actually, like, in my mind, I physically drag this column over to this row. That's the only way I can remember to do matrix multiplication. Okay. 20, that goes to 20 over 10, which is 2. That becomes 60 over 10 is 6. That goes to minus 30 over 10 is minus 3. Wow, that actually, okay. And that becomes 10 over 10 is 1. Okay, let's get some nice full numbers out of that. Okay, now we still have the 1/10, the 3/10, 7/10, and minus 1/10 to deal with. Right? That's a 3. That should be a 3, not a 7. I was wondering where that 7 came from. I just have messy handwriting. My V inverse had a 3 there. Okay. One last multiplication, and then apparently we got our eigenvectors along the diagonal. 2 over 10 plus 18 over 10 is 20 over 10 is 2. That times that. 6 over 10 minus 6 over 10 is 0. Aha, okay, that's good. Minus 3 over 10 plus 3 over 10 is 0. Good. 3 over 10, minus 9 over 10, minus 1 over 10 is minus 1. Okay, so that means the eigenvalue for 1, 3 is 2, and the eigenvalue for 3, -1 is -1, as far as I can tell. I guess you could compute it back to verify, but I guess I get 2 and -1 for the eigenvalues. Unless I did something wrong. Minus 20 over 10, minus 1 over 10? Where's minus 21 over 10? I don't remember minus 21 over 10. Oh, if you talk about, that used to be a 7. It's supposed to be a 3 though, because my V inverse was 3, but I accidentally wrote 7. I had to correct it later. This is supposed to be a 3. You got 2 and -1? Okay, at least that matches. You can't read the lower right answer? Oh shoot, I'm writing too small. But I get 2 and -1. Okay, you know what? We can be even better here. I'm sure there's an eigenvalue calculator online, right? Set a minus 1 over 10 in the lower right, second matrix, second to last line. Lower right, second matrix. Minus 1 over 10 is right there, yeah. So it was 3 over 10 times minus 3 over 10 plus minus 1 over 10 times 1. And, you know, we don't have to play guessing games, I guess. 2 and -1. Okay, it worked. Okay. So I guess we agree then, Camillus. And the general solution of the given system is second order differential equations. I've never done that before. I'd have to look up the format of it. I imagine you still have e's and sines and cosines. Dude, show me the second order. This thing is 48 pages. Second order. Oh no, that's not for the system. Ugh. Come on. Well, that's not even. Ugh. Kim, so were you given or if you do want to see what I would say for part B, were you given what the format of the solution should be? 'Cause I assume that once you have the eigenvalues and eigenvectors, you can still plug it in to something. No worries, SPQ. Yes, SPQ. I'm like not at all comfortable with matrices, which is why like that only kind of makes sense to me. I'd have to spend a lot of time to actually understand what you're saying. So the way that Zach described was easy for me to follow. I'm on like a live stream. Why can't I find anything about this? Okay, let me put my mug away because I'm out of tea. Just show me things that are for second order differential equations on their own, not for a system. Will that force it to only show me things with system? I guess I could just look at the stack exchange stuff. It's just probably not going to explain everything that I want. Okay, this is basically the same type of question. Hmm. I mean, their solution is just for x prime, basically, but they're just calling it x. Wow, the quadruple dot? That's a bit more complex than what I have. Wait, so Kimulas, are you still here? I'm getting a little confused on like how to get the final answer here, but like, were you provided anything about like what the form of the final answer should be? All right, I'm not seeing anything from you, Kimula, so I'm just going to put a pin in this for now because I'm a little lost on part B, and I'm just going to move on for now unless I see you typing anything else in chat. That does not sound very enticing. Sorry for my handwriting. Definitions are good and correct. Side angle side. Two sides include angle between them of one triangle is congruent to the other. Angle side angle. Is it the side between those two angles? Or is it a... That is the side between those two angles. Okay. Then angle side. That's the one. Okay, yeah, never mind. Two angles with the same side, but the side is not between the two angles. It's one of the sides of a different angle. That doesn't make any sense to me. If it makes sense to them, then more power to them, I guess. M is the same, and then they take GU and RE as the... Okay. I mean, their drawing's right. Can I just link them to this page, actually? Or is there like a general... Yeah, I won't link them to this page. AAS, ASA, SAS. You want to see it? Sure. They're just asking to verify the definitions that they said. Yeah, I think so too. My link works good. Okay. Okay, someone else is already talking. That was a whole essay. There's geometry involved. I didn't want to see it. Are they talking about the rotation matrix here, or the unit vector of x prime? Oh God. What is going on in this image? So maybe the original vectors are x and y, and that goes to x prime and y prime. The lengths change, which confuses me, but is this the rotation matrix? This feels like it's just the rotation matrix, but they've already done the multiplication part. It's an actual question here. Okay, so just like y is... Okay, let me see if I can find a page on the rotation matrix. So I think that would answer their questions. Okay. Nope, what a Brocard triangle is. I feel like I've heard someone else ask about that somewhere. Ooh. They already have a, an answer. I guess a confidence interval for proportions. The link works if I click on it. Where's the little Z or T value coming from? Oh, maybe. I want to know why the rotation matrix works. Maybe. It might be scalar. I don't understand exactly why the projection acts like that. And explain why it works. I know it's the usual way to rotate a vector by a given angle. I don't want to like say something wrong here because this really isn't something that I'm good at. So getting the critical value. Yeah, that's a good call, Dan. Let's see if we can get them. I mean, for proportion, the critical value is always the same, like process, whether it's proportions or not. Confidence interval. I mean, given 95% confidence, you'll do, either an inverse norm or you'd 0.95, or you'd look in the Z table for the closest thing to 0.95. So actually, it kind of depends on stats get taught in very different ways depending on the teacher, whether you use a table or a calculator or stuff like that. Oh wait, for confidence interval, do you divide it by 2? Maybe 0.975. So confidence interval is two-tailed, isn't it? I remember like for 95% it's 1.68, but or something like that. Yeah, so okay, you do divide by 2 for confidence interval. Hmm. Or 1.96 is for 95%. Oops. 1.61 is like 90% or something, maybe. This might be the best explanation that I can quickly find. I'm just gonna say everything in terms of Z because they say proportions. The middle 90%, 95%, whatever confidence level of the interval is. Is the middle, whatever confidence level of the normal distribution. Would do, and like your formula there, Dan, so I'm gonna steal it shamelessly. $95. Oh no, I hit enter. Yeah, I think that you personally invented that, Dan, and that you have a copyright on it. And look for the corresponding z value that goes with wait 2.5%. That's 0.025 at 0.025 or 0.975 inside the table, or do inverse norm in a calculator. 0.975. This explanation as well. Okay. Struggle explains content without the normal distribution image with respect. Yeah, exactly. So, it is hard to explain like with words. Hopefully the website helps him out too. Okay, so thanks. Let's let that one marinate. They haven't learned. Wait, they've learned about vectors but not matrices? Oh my god. Well, I mean, and it's okay to learn about vector formations, I guess, but I feel like they're just doing rotations is something that really is so much easier with the matrix, and I feel like they're being taught matrices while avoiding, like they're learning the aftermath of multiplying by the rotation matrix and having to memorize it as a formula. I don't remember, did I learn, when did I even learn about vectors? I didn't learn about vector matrices until like college, until I did a linear algebra course, I think. I never used them before that, even though we probably should have. Is my guess. So I think they're just supposed to like do this as a formula and take it as a fact, without knowing how it works. Okay. Let me look at this ping that I got. What's the other person I replied to? Oh, okay. The person closed it. Oh, they didn't type it in quite right, but it'll get cleaned up on its own eventually. I'll let that one sit. So the -1 exponent means you do have to flip the inside of this, but you end up with just x can equal 0 again, which is already true from here. Is there anything else that we can't, that doesn't make sense here? Wait. Apparently f of x can't exist between -1 and +1? When x is less than 1, this exponent is negative entirely. And x being less than 1 doesn't have any effect, well, except for x equals 0, it doesn't have any effect on this. So when x is less than 1, it can't also be 0, which is already true. When x is greater than 1, I don't see why this would have to be the case. I'm not sure though. People are already typing. Why cosine and not sine since it creates a right triangle? I think I told them why. But I guess I'm not explaining it well. Which, I mean, I know I'm not explaining it well, but no one else is replying. And I feel like I at least have something that's a little bit helpful. Okay. Okay, so you express the vector in polar form with this derivation at least. That means x prime, y prime is the same thing, but with v plus theta instead of, or not, that's new, I guess. But they're just writing v there, so I feel like that's cheating. Why does theta get respect but not new? Anyway, spinning the brackets using trig identities. Okay, well, so I think the answer to their question is that it comes from trig identities and probably isn't that significant. But involves converting it into polar coordinates. And using trig identities. I don't think the cosine being involved rather than sine is that significant. It just comes up because of the trig identities being used. It's not like they want like a geometric interpretation of this, like, and I'm not sure that there is an easy one of the kind that they're thinking of. Like, that's more like based on triangles, I guess. Which, I mean, it is based on triangles, but I don't think I feel like it's not in the way that they're hoping. In link, which doesn't involve matrices until the very end. Direct reason why the formula is the way that it is. It sounds like you're asking. So I think they want some explanation like the sine is there to rotate the x component by a certain amount, and the cosine is there to do the rest of the rotation or something like that, and I'm not sure if it is like that. Okay, well, I assume that's just trig. 50 times sine of 30? Why do they do cosine? Am I doing... Wait, 30 degrees from the horizontal. Let me... Okay, so this is physics. Let me make sure I'm not being really stupid, but I think you're supposed to do sine. Momentum, x and y direction, I guess. Let's just... Okay, yeah. For along the y-axis, they use sine here. I have about collisions, but do you miss any geometry? If you want to count the rotation matrix as geometry. If you want to count... Hey, Aller. Well, here, Jade, you can be a little samey check. I don't know if you know this offhand, but they're asking for someone to check their work. Yeah, the normal distribution is a geometric shape, I guess. They're saying that the y direction for momentum is what is the momentum times cosine of 30. I'm like 99% sure it's sine of 30. I'm just say I believe that it should be sine of 30. Show the question, yeah. So the angle is given as 30 degrees from the horizontal, which there could be a trick question they gave us 30 degrees from the vertical. Which you would want cosine, but so I mean technically it's more physicsy, but I feel like it's a simple enough situation that I feel confident enough to answer it. Wait. No, it should be sine. They said it's cosine, but I'm pretty sure it's sine. I'm posting this because I feel pretty confident. No, wait, you're saying it's sine. Oh my god. Not okay. I'll draw a picture. Why would this be cosine? Dude, oh my god, this marker like dried on a bit. It's taking forever to erase. Did I ever turn my humidifier? I'm gonna turn my humidifier down. 1 second. Oh, okay. Oh my god. The humidifier is even on and this thing dried out. Okay, even the humidifier isn't about this, but your brain is still in the off. Okay, so now you agree that it's sine. Okay, yeah. I was like, okay, I don't think I need to draw the picture. It's like I'm like 99% sure this is sine. It's that anytime physics is involved, I get scared. 79 times 67, oh my god. Okay. 79 times 67? Okay, it's like 80 times 67. Which is 67 times 8. 67 times 8. 8 times 7 is 56. So 6, carry the 5. 6 times 8 is 48, plus 5 is 53. So 5, 3. What did I say for my first digit? 536. So 536 minus 67. Oh my god. Oh, that's such a mean number. 536 minus 67. Is 536 minus 67. Wait, I need to add a 0 because it's 80. 5360 minus 67. 5360 minus 67. 5360 minus 67. 5293. Final answer. Hey! Okay, I'll you know, I still have to see it for myself. I don't know why. 5293. Okay, I actually got one right. Okay. Is he on streamer? Oh, okay. I saw his live, but I wasn't able to catch him. Really? So you know all three of the angles. You know a side. I think that should be enough to solve this triangle. But how? Do you do law of cosines with different sides and get a system of equations? Is there anything easier? Like, maybe would law of sines be a thing here? I don't remember how the law of sines works. Oh yeah, law of sines is probably it here. So, okay, let's see if I can apply this right. You can draw a diagonal line from the bottom right. Let's see what you're saying, Dan. Diagonal line from the bottom right to a point. Law of sines is more efficient. Okay. Yeah, I was thinking about like drawing lines and like trying to use the Pythagorean theorem, but I think law of sines is gonna be easier. Okay, so let's I need to make sure I'm applying it right because I'm not good at keeping track of my angles and stuff. So let's draw the triangle as we're given it. – 78 on top, 42 on the lower left, right. 80 plus 40 is 120, so that's 60. Yep. We got 5.4 down here. So with the law of sines, I'll look at that. Let me do this, Jed, and then I'll look at that link. Law of sines, 5.4 over sine of 78 is equal to, oh yeah, x is right there. So I don't actually need to get that third angle. This is definitely just a law of sines problem. It's equal to x over sine 42 is our setup. Okay. And let's just plug that into Wolfram and make sure we get something that's half reasonable. Uh, 5.4 times sine 42 over sine 78. Sure, Wolfram is using degrees. Sure is. 3.69. Hee. That's pretty reasonable to me. I got 4, but I don't know if it's right. I get okay, yeah. Not quite that answer using law of sines. Okay, let's see what your thing is, Jed. What? Click the Desmos app for an animation. What? How much time does it take to do this? This does feel like a Flash game, Dan. That's a good call. The Triforce! They made a brain? Is that... Was that a pixelated dick, or was that just me? Am I just seeing things? Okay, that's pretty cool. This must have taken so much time? He's not the impersonator? Dude. That's crazy. What people can do in Desmos. Oh, okay. So I was person to get the right answer, I guess. What went wrong? Double integration by parts. It's easy to make a mistake with this. Whoa. No, okay, that's okay. This isn't the exact way that I set up integration by parts, which is what throws me off, but... Wait. Yeah. Why is there another cosine x there? They said there's... Wait, no, these are two... Oh, never mind. I see. This is their integration by parts for the first round. Okay, so yeah, they derived dv, and they're supposed to integrate. Actually, wait, what the heck is... I have a really hard time following their work. So, their notation is really... They should be deriving the x squared. It seems like maybe they did. Well, no. Yeah, their setup is very weird, and I think they... I think it's making them make errors when they plug into the formula. Strawberry. Yeah, sure. Feel free to just put your question in chat there. I'm probably not going to do math for a ton longer, so oops, no, don't reply to that one. Hopefully, if they're still playing, I'm going to be doing Lethal Company with Astro and his friends. I started my stream early today because I horribly... I made a horrible mistake when doing the time zone conversion, and they've been playing for hours, and I said that I would play with them like pretty close to when they started, and I added 3 hours going from Eastern to Pacific rather than subtracting 3 hours, so I was like, horribly late. Is off. For your first integration by parts, I would take u equals x squared. I should probably do this with LaTeX. U equals x squared. So du equals 2x dx, and take dv equals sine x dx. So v equals, sine it integrates to minus cosine. And go from there. Because you need to derive the x squared. That's the only way you're going to make progress, I think. Okay, in strawberry, what does that say separates an infinitely sided regular shape from a circle? Oh! Yeah, we were talking about this concept. We didn't like quite get to that conclusion, or like a very we haven't talked about like necessarily the conclusion if you have a literally like infinite sided shape and how it relates to a circle. It's definitely true that as you increase the number of sides of the shape, it's going to approach a circle. I don't know if literally an infinite-sided shape is a circle, though, like I think you're asking. I guess so, Dan, you're right. I'm just having trouble with like the actual infinity bit. Infinite-sided regular shape from a circle. So I guess, Strawberry, the answer, as far as I know, is nothing. I don't know if that's a technically correct answer. Yeah, I'm right there. I agree with Dan. Like, that's my understanding, but I don't know that. So the thing with integration by parts is there's kind of just different ways you can integrate by parts. You can either, okay, let me just keep it a bit, let me just do the more basic explanation. Degrades as you derive it. Like x squared. X squared becomes 2x becomes 2, and it gets easier to integrate. If you were to derive sine, it would just cycle between sine and cosine and not help you, usually, but there is sometimes an exception. So there's integration by parts where it's an infinite cycle, but you can like, add one integral to the other side and divide it by 2, which I don't know if this person has done that yet. Respellet said no, weren't able to tell you why. Yeah, that seems like one of those very technical, like theoretical things where I wouldn't be able to give a good explanation, and I don't know it offhand. Because it could be a thing where like the limit is a circle, but the actual thing isn't a circle. If that even makes sense, I don't really know. Like, what exactly is an infinitely sided shape, I guess. I guess that's the idea that I was trying to say with that, Strawberry. I have no idea how valid it is, though. Like, that's just completely random, like, bullshitting from me, basically, for what I think might happen, but I don't actually know, so... I don't want to kid you into thinking that I have any sort of, like, expertise on this. So the person says they see. See, I mean, because we're working this exact problem with Zach, aka e to the 2i pi. So I don't know if he investigated that exact question about it, but he may have like recently researched it. Have you tried asking him? A behavior statement where n approaches infinity, shape n approaches a circle. Okay, that person closed out. Good. That's what I'm thinking too. But like the limit can exist when the function itself doesn't exist. I'm just thinking in terms of like, you know, a calculus 1 class. So I wonder if it's some kind of technicality like that, which is why I'm saying like, you know, some kind of asymptotal thing as what you said, but I don't actually know. I'm completely guessing when I say that. It's like a possible explanation for why people would say that it's not true.